All right, so in our notes today, I'm going to work up into number 12. We're starting to look at area. So let's see, area. Before I look at the question, let me explain what an area is. I know I can look for information. Like if I was looking to buy a house, it tells me the area, but actually I want to say area is how many squares there are. So an example, let's say I had a figure. Let's say I had a figure like this, and it's all in squares. The area is how many squares are there? And we can literally count. I know the measurements. We might see measurements sometimes like, for example, in this case, we might have this as 24. And then we have measurement as squared feet. Right? Something that's how we see it. And then another person might say 24 and they say feet square, right? Basically square feet. The area, what area means in this case is how many squares are there? We know there's 24 squares. Now the measurement, feet squared or square feet, is how big is each square? Like each square is 1 foot by 1 foot. So we have an idea. Like if I'm going to measure something as big as California, my squares should be miles square, right? Something big squares. If I'm going to measure something as my computer, I can go inches squared. I'm going to measure something as big as my phone, I might go inches square as well. But area means how many squares are there? One of our areas, the first one we're going to be looking at is the area of a rectangle. Let's say I have a rectangle here, and I have a 2 by 3 rectangle. The 2 by 3 means in one measurement, there's 2 squares going down, and then the 3 on the top means there's 3 squares going up. We can literally count them. 1, 2, 3, 4, 5, 6. The area is 6. But for rectangles, a shortcut, an easy way how to do this is, let's find a 90-degree angle. So I'm going to find a 90-degree corner, and I'm going to multiply the two numbers that make that corner. So 2 times 3, right? 2 times 3 gives me 6. So that's the shortcut. This formula is, how are we going to get the area of a rectangle? Literally, we can count them, but a short way or a faster way is just multiply the two sides that make a 90-degree angle. So an example, let's take a look at question number 1. Use a calculator if you need to. I'm going to look for a 90-degree angle. Just to choose one, I'm going to choose this one. It doesn't matter which one. And I'm going to multiply the two numbers that meet at the 90-degree angle. So I'm looking at 11.7 and 11. And I'm going to go 11.7 times 11. I multiply those two, and my answer is 128.7. I see measurements, centimeters square. So what the measurement centimeters square, what that means is how big is each square. Now, I'm not interested on the homework. I'm not interested on the measurements. So you don't have to write centimeters squared. I'm interested in, do you know how to do the work? So just give me the number. I'm going to round it to the nearest tenth. So 1 decimal place. If there's more than 1 decimal place, I'm going to round it to the nearest tenth if necessary. Looking at question number 2, right? Any degree angle, any 90-degree angle, I'm going to choose this one. Right? I got choices. Just choose one of them. I'm going to multiply the two numbers that meet at that corner. So this is one of my sides. This is the other side. So I'm just going to go 9 times 9. So as a matter of fact, let me write it even down. 9 times 9. I'm multiplying those two numbers. And my answer in this case is 81. So I guess let me come back to number 1. And let me just go 11 times 11.7. And that's how I got the 128.7. So for rectangles, it's not that bad. Just multiply the two numbers to make the 90-degree angle. Now, when we have parallelograms, I'm looking at question number 3 and 4, they look like a slanted rectangle. Interesting part, very interesting part. Let me just draw another parallelogram here. We call those parallelograms because two sides are parallel and the other two sides are parallel as well. Yeah, you guys learned that in the first semester. Talk about parallelograms. Interesting part of a parallelogram is if I was to cut a triangle here, if I was to cut a triangle, my parallelogram, and place it on the other side, interesting part is that it will give me a rectangle. If I remove a triangle from one side and I place it on the other side, it gives me a rectangle. Parallelograms, they look like slanted rectangles. I can make a rectangle out of it. Right? If you notice on question number 3, there's a triangle here on the left. I could place it on the right. I get a rectangle. So parallelograms, I'm going to treat them like a rectangle. For the previous 2 examples, when we're dealing with rectangles, I said multiplied the two numbers that meet at the 90-degree corner. In that case, looking at my rectangle, I'm going to look for my 90-degree corner. It is made by the numbers 9 and 4.9. Once again, find the 90-degree corner. Sometimes it's inside the figure, like we see number 3. Sometimes it's outside, like we see number 4. I'm going to multiply the two numbers to make the 90-degree corner. In this case, I'm going to go 9 times 4.9. Use a calculator if you need to. 9 times 4.9 is 44.1. That's it. Don't think that you have to use every number given in the problem. There are some numbers, like 6.9, that I did not use. So don't think you have to use every number. So remember, I'm just looking on parallelograms. I'm just looking for the two sides that make the 90-degree angle, and I'm multiplying those out. I'm going to treat it like a rectangle. So I have a question is, why didn't you round the first one? 128.7. Well, it is rounded, 128.7. I'm going to round my answers to 1 decimal place. Right, all my answers are rounded to 1 decimal place if necessary. All right, let's take a look at number 4. Parallelograms. I just said it right now. Parallelograms, they look like a slanted rectangle, and I'm going to treat them like a rectangle. My focus is at the 90-degree corner. That 90-degree corner is made by the number 6 and this other 6 at the bottom. The dotted line that we see at the very bottom is, if I was to extend this 6 from the bottom, if I was to extend it, that's how we see the 90-degree angle. But the 90-degree angle is made by 6 and 6. So let me multiply those two numbers. 6 times 6 is 36. So 36. Again, if you have decimals, because some of our answers will be decimals, if we have decimals, make sure it is rounded to the nearest 10th. That means 1 decimal place. This is not a decimal. And again, if we were doing measurements, this is yard square, right? Square yards. That means each squared is 1 yard by 1 yard. But for a homework, I'm interested in just the number. Now, coming back, let me come back here to the side. We know how to get the area of a rectangle. Let's say I had a rectangle that is 3 by 4. Let's say I have a rectangle. I know rectangles, I multiply the two numbers and make the 90-degree corner. There's a 90-degree corner there. As a matter of fact, let me do another 90-degree corner there. But I'm just focused on the one on the top left. I know the rectangle, the area of that rectangle will be 12, right? Because 3 times 4 is 12. Interesting part is that if I was to cut my rectangle in half, let's say I cut my rectangle in half, I know the whole rectangle is 12. Because I cut it in half, I'm gonna say this half is 6 and this other half is 6. Again, I cut my rectangle in half. The interesting part is that half of a rectangle is what we call a triangle. Notice I highlighted in blue. Half of a rectangle is a triangle. So what I'm going to do for triangles, I'm going to multiply the two numbers that make the 90-degree corner. So the two numbers that meet at the 90-degree corner, that's my rectangle. But for a triangle, I'm going to divide it by 2. Here I have a question is, do we just put the number squared or the number itself? Just the number. Just the number. So coming back to a triangle, what I just said right now is multiplied the two numbers that make the 90-degree angle and then divided by 2. The reason why we divide it by 2 is because a triangle is half of a rectangle. So looking at question number 5, I'm looking at my 90-degree corner, which is right there. It is made by the numbers 3.8 and 2. The dotted line is just for you to see that it does extend and make the 90-degree corner. So I will go 3.8 times 2. To begin with, I multiply these two numbers out, 3.8 times 2. But I know that's a rectangle. For a triangle, let me divide my number by 2. I divided by 2 because I said a few minutes ago, I said a triangle is half of a rectangle. So I will always divide by 2. All right, I know 3.8 times 2 is 7.6. 7.6 divided by 2 is 3.8. If we're interested in measurements, it's centimeters squared. But in my case, I'm interested in just the number, just 3.8. Take a look at question number 6. The 90-degree corner is made by the numbers 10 and 5.3. So I'm going to multiply 10 times 5.3. I know if I multiply 10 times 5.3, I get 53, but just multiplying these two numbers gives me a rectangle. So let me divide by 2 because a triangle is the half of a rectangle. 53 divided by 2 is 26.5. So my area of this triangle is 26.5. Don't forget to divide by 2. And we don't have to put the units, just the decimal, just the number. So for our answered, my answer will just be 26.5. Don't worry about kilometer square, just the number, 26.5. Here I have a question is, can you explain again why we divide by 2? I'm still confused. It's fine. The reason why we divide by 2 on triangles is because a triangle is half of a rectangle. Let me come back to here. If I multiply the two numbers that make the 90-degree corner, so 3 times 4, I'm looking at the red numbers, 3 times 4 gives me a rectangle. You can see the whole rectangle, which is 12. But a triangle, you can see the triangle now in blue. The triangle is half of a rectangle. So when we multiply the two numbers that make the 90-degree corner, that's a rectangle. We end up dividing by 2 because a triangle is half of a rectangle. That's why on questions number 5 and 6, notice for each of them, I multiplied the two numbers that make the 90-degree corner. And then I divided by 2. Again, divide by 2 because a triangle is half of a rectangle. Then we're going to move into one figure that tends to give us a little bit of a hard time, which we're going to call trapezoid. I'm looking at questions 7 and 8. We're going to call this trapezoid. But before I look at our examples, let me explain how trapezoids work. Trapezoids, they have two sides that are parallel. Let me call one of them base 1, base 2. Right? They have numbers. We'll be using with numbers. But for right now, let me call it base 1, base 2. Those are the sides that are parallel. The other two sides are not parallel. But for the area of the other two sides, I don't care. I don't need that. Another information I'm going to need is the height of the trapezoid. Let me just say like this dotted line, let me call it H for the height. Interesting part of a trapezoid. I'm going to derive the formula. I can just give you guys the formula and say, this is the formula and use it. But I like to explain where formulas come from. Now, on this trapezoid, if I was to cut the height in half, if I came over and I decided to cut this in half, and the top part, I'm going to flip it over. So let me write it in green. If I was to flip it over, it will look like this. So the top part, let me do this. So I cut it out, I flip it over, and then I put it at the side. I know this little part right here, it is base 1. Interesting part, the interesting part of a trapezoid is that I just created a parallelogram. And I know parallelograms, I treat them like rectangles. The only thing is that the long side of the trapezoid is base 1 plus base 2. Notice I'm adding the two bases. See how here's base 2, here's base 1. So notice I added the two bases. That's the long side of my parallelogram. The height of this parallelogram is the original height divided by 2. Or let me just say, let me actually write this as height divided by 2. Let me just write it like that. The height of the original trapezoid, I cut it in half. Notice on the picture how I cut it in half. So that's actually going to be the formula for a trapezoid. I'm going to add the two bases. Notice I have base 1 plus base 2. So I'm going to add the two bases. And I'm going to multiply this by the height of by the half of the height, or half divided by 2. Let me explain that in an example. Number 7. First of all, let me add 3.9 plus 1.7. Notice I'm adding the two bases, 3.9 plus 1.7. Whatever I get, I'm going to multiply this by 1.8 divided by 2, right? The half of the height. Notice how the height is 1.8. All right, so first of all, let me find out what's 3.9 plus 1.7. I'm going to type this on my calculator in parts. I'm not going to type it all at once because I might type it wrong. Right? There's a very, very easy way how to get confused, or there's an easy way how to type it wrong if you type it all at once. So don't. I'm just going to add the bases, 3.9 plus 1.7. That gives me 5.6. The first parentheses. 1.8 divided by 2, that is 0.9. Now let me multiply those two numbers. 5.6 times 0.9 originally gives me 5.04. But I know I have to go to one decimal place, not 2. one decimal place. My instructions will say round it to the nearest tenth. So I see the second decimal place is too small. Too small is 4 or less. So I'm just going to ignore it. My number is 5.0. Now the 0.0, 5.0, it is just 5. Do expect decimals. Most of them will be decimals. Let me take a look at number 8. First thing, I'm going to add the two bases. And bases are those two sides that are parallel. So my first parentheses, I'm going to go 1.3 plus 4.9. I'm adding the two bases. And then my second parenthesis is going to be 2 divided by 2, right? The height divided by 2. 1.3 plus 4.9. My first parenthesis is 6.2. The second parenthesis, 2 divided by 2, that's 1. When I multiply my two parentheses, 6.2 times 1, 6.2. My answer, it's okay to have a decimal, but just one decimal place, which is what I have. So 6.2. You're going to practice on these figures. So trapezoids might give you a little bit of hard time. Make sure, let me come back to my lecture here at the side. Right, add the bases, and then you're going to multiply this by height divided by 2. All right, another figure might give you a little bit of hard time is regular polygons. A polygon, what a polygon is, poly means many, gon means side, so polygon. Polygon is a figure with many sides. Sides must be straight. All right, so polygon is a figure with many sides. I know how to get the area of a triangle. And I'm going to use the idea of a triangle to get the area of a polygon. Now, we call this a regular polygon, which means that all the sides are the same length. So in this case, for number 9, I'm going to say this measurement outside is 10. You guys can see where I got the 10 from, because I said all the sides are the same length. And I'm going to use the idea of a triangle. I know a triangle, it's made, there's a 90-degree angle in my triangle. So I'm going to be looking at, let me create this triangle here. You guys can see my triangle. I know how to get the area of a triangle. I multiply the two numbers that make the 90-degree angle. So I have to go 8.7 times 10, and then I divide this by 2. That's just for my one triangle. Because remember, for the triangle, I multiply the two numbers that make the 90-degree angle, but then I divide it by 2. And the divided by 2 is because it is half of a rectangle. If I just go 8.7 times 10, that's a rectangle. I divide it by 2 because it is half of a rectangle. So again, this is just my triangle. Whatever I get from my triangle, interesting part is that I notice my polygon is in many triangles. There's the one triangle. I'm going to highlight the one triangle I was working with. There's a second triangle. There's a third, fourth, fifth, and sixth. This figure has 6 triangles. I know how big is one triangle. So for me to know how big is the whole polygon, my result for my triangle, let me multiply this by 6. Now, the interesting part is 6 is how many sides there are. So if I gave you guys a polygon with 5 sides, find the area of the triangle and then multiply it by 5 because there are 5 sides. If I give you a polygon with 30 sides, I'm not going to be that crazy, but if I did with 30 sides, find the area of a triangle and then multiply by 30. All right, so let me just type this in. 8.7 times 10 divided by 2 and then times 6. I'm going to type it all at once. So I went 8.7 times 10 divided by 2 times 6, and it gives me 261. That's it. If you have decimals, rounded to the nearest 10, so 1 decimal place. Let's take a look at number 10. I know each measurement outside of my polygon is 14.1. So this side is 14.1. And I'm going to focus on a triangle only. You guys can see my triangle. So for that triangle, I'm going to go 17 times 14.1 because I multiply the two measurements that make the 90-degree angle, 17 times 14.1. But if I just do that, that's a rectangle. So my result, let me divide this by 2 because a triangle is half of a rectangle. I count how many sides there are. Let me count in blue. There's 1 side, 2 sides, 3, 4, 5, 6, 7, and 8. There are 8 sides. So if I was to cut this figured in triangles, I know there's 8 triangles. So whatever I got for this, I'm going to multiply this by 8. So I'm just going to type everything at once. 17 times 14.1 divided by 2 times 8. My calculator says 958.8. Yeah, somebody else also got 958.8. Good. Yeah, definitely. So all we do for regular polygons is focus on one triangle. Just get the area of a triangle and then multiply it by how many sides there are. So regular polygons are not that difficult. Basically triangles. That's what you're looking at. Question number 10 is a triangle times 8. So there's 8 triangles. Now the nice ones are Kite and Rhombus. These are the last two for today. Interesting part of kites is that my diagonals, the sides in the inside, they cross at 90 degrees, but I'm not quite going to work on the angles for right now. I'm actually going to look at the side. There's one side that gets cut in half. The other side does not. I notice that there's a measurement to 3. So I'm going to say this other side, it's also 3. Like I said, one of my sides gets cut in half. Now for a kite, what I'm going to be doing, let me look at my diagonals. The diagonals again are the measurements on the inside. The two segments that cross at 90 degrees. I mentioned the 90 degrees in the center. So one of my diagonals is 6, right? You guys can see 3 and 3, 6. One of my diagonals is 6. The other diagonal is 13, right? 4 and 9, 13. So once again, I'm focused on my diagonals. If I was to multiply 6 times 13, again, those are the measurement of my diagonals. One diagonal 6, the other one's 13. If I was to multiply those two, 6 times 13, that will give me a rectangle. But notice the kite, it's only half of the rectangle. And the reason why I said it's only half, because look on my top left squared. I'm just focused there. Notice how the kite is only half of the square, or the rectangle, I mean. At the bottom, there's another rectangle, and my kite is only half of that. On the top right rectangle, my kite is half of that. And the bottom half, the bottom right, my kite is only half of that. So my kite is half of the rectangle. So whatever I get, I'm going to go 6 times 13. And whatever I get, I'm going to divide this by 2. So all I'm going to do is I'm going to multiply my diagonal. Probably we can Google what's the formula for the area of a kite. And Google will say diagonal 1 times diagonal 2. And then my result, I divided by 2. And that's exactly what I'm going to do. 6 times 13 divided by 2. So I'm going to type everything at once. 6 times 13 divided by 2 gives me 39. I have a question here. Where do you get the 13? You see my long diagonal. One part of the diagonal is 4. The other part is 9. 4 plus 9. All right. So you're going to add the whole diagonal. You're going to run into kites. As a matter of fact, on the homework, it will even say, find the area of a kite. We might have decimals. If we do, round it to 1 decimal place. Now, rhombus, find the area of the rhombus. Rhombus, it's pretty much the same idea as a kite. The only difference is on the kite. Let me come back to the kite. On the kite, only one side gets cut in half. One of my diagonals, you guys see 3 and 3. There's a diagonal that was cut in half. The other one is not. For a rhombus, both diagonals get cut in half. So looking at the blue diagonal, I'm going to say, I see an 8. So I'm going to say this other side at the bottom must also be 8. I see a 12. So I'm like, all right, this side is also 12. I need to know how big are my diagonals. My blue diagonal, I'm going to say it's 16. Because 8 and 8, right? 8 plus 8 is 16. My orange diagonal, I'm going to say it's 24. Right? 12 and 12 is 24. So I know, and the interesting part, they also cross with 90 degrees. So I know 16 times 24 gives me a rectangle. That will give me this big rectangle. But my rhombus is also just half of my rectangle. So I'm going to divide this by 2. So I'm going to go 16 times 24 divided by 2. So you have to go one diagonal times the other diagonal. And diagonal, again, I'm talking about, I'm going to do it as dotted line, dotted segments are these two in the center. Those are my diagonals. I have to multiply one diagonal times the other diagonal. So 16 times 24 and then divided by 2. In this case, my answer is 192. Diagonal 1 times diagonal 2 divided by 2. Be careful. Be careful what information I give you. I might not give you all the information that you need. But there's some information that I'm missing and you can figure out. Question number 11. One side, 1, 3, you could figure out. So I figure it out. Question number 12. An 8 and a 12. I was missing an 8 and a 12. So be careful. All right, let me zoom out. Let me zoom out so you guys can take a screenshot of the work for today. Let me stop right there so you guys can see it.